Okay, let's look at number 9. We've got an IV order that calls for the addition of 45 milliequivalents of calcium carbonate. You have a 25 ml vial of calcium carbonate, 4.4 milliequivalents per ml. How many mils of this concentration do you need to add to this IV? I did this, I believe, with allegations, and I told you that usually they would add in these kind of supplements or nutrition to like TPNs. And when you're working with milliequivalents, you basically take what you need and divide it by what you have. And you need to be sure it is per 1, and it is already per 1 milliliter, so we're good. So we just have to take what we need, which is the 45 milliequivalents, and let's divide that by what we have, which is the 4.4, and you get 10.2 milliliters. So you would actually add 10.2 milliliters of calcium carbonate to this TPN bag for number 9. Number 10 is an infusion rate. So we've got an infusion rate of an IV. It's going to run for 12 hours. My volume is 800 milliliters. It wants to know the infusion rates in milliliters per minute. So there's a couple ways you can do this. The first thing let's do is let's get it milliliters per hour. So we've got 800 milliliters, and we're going to run it over 12 hours. So we are going to get, I believe you get a weird fraction here, and I don't like that number. This many milliliters per hour. Okay, well, to get it per minute, we would just simply divide it by 60 because there's 60 minutes in an hour. And I believe you end up with another weird number of 1.1 repeated. So you may see a 1.1 as a multiple choice, or you may see they may even bump that down to 1 mil per minute for you. Okay, let's flip over to the next page, and number 11. It says the standard pediatric dose for cefazolin is 20 milligrams per kilogram per day. The order is written for 150 milligrams 3 times a day. The infant weighs 8 pounds. It wants to know what the dose is. The very first thing we're going to have to do is get our 8 pounds to kilograms. Remember, there are 2.2 pounds for every kilogram. So I'm going to take 8 pounds and divide that by 2.2. And that, when I do that, I get 3.63. I think it's repeated again, another weird number. So we know the infant's weight in kilograms now. So we can figure out kind of the dose here. Let's see. So it's supposed to be 20 milligrams per kilogram per day. The baby weighs this many kilograms. Let's multiply that times 20 because we're going to give 20 milligrams per kilogram per day to kind of see what our dose should be. And when you multiply these two together, you get a dose of 72.72 milligrams per day is what the standard pediatric dose is. Now, let's look and see what the rest of our problem says. It says the order is written for 150 milligrams 3 times a day, which is more than double what they should be getting in a day. So I would say my dose here is too high. If I were to see this and I were to know my standard and I would see that a physician wrote this, I would immediately call and just make sure, of course, in a very respectful way. Sometimes doctors don't like to be questioned, to make sure that they haven't made an error, because this would probably cause an overdose in a patient of this weight. This is a very typical question. Just kind of, it's giving you multiple steps here to kind of checking to make sure you're meticulous, checking to catch errors. So you're not only applying those mathematical skills, but you're also having to be meticulous. Okay, number 12. How much cough syrup will the patient take in 24 hours if the dose is 2 teaspoonfuls every 6 hours? Okay, so we're going to take 2 teaspoonfuls. We need to get that to milliliters. 1 teaspoonful is 5. So multiply that times 2. So my dose is 10 mLs. And we're going to take that every 6 hours. So how many times in a day would that be? Well, that would be 4 times a day. So we're going to take 10 mils 4 times a day. Well, 10 times 4 is 40 mils per day. How much cough syrup will a patient take in 24 hours? Okay, well, 24 hours is a day, so it'd be 40 mils is your answer. Okay, the appropriate size container for the dispensing of 180 ml medication in ounces. Well, we know that there's 30 mils in 1 ounce. And we've got 180. So I would just take 180 and divide that by 30, and you should get 6 ounces. Okay, number 14 is going to be an allegation. We've got a prescription for dextrose 25%, 1,000 mils. We have a 70% and a sterile water. How much of each is needed? So remember, when you're working with allegations, you take your higher of what you have and put it on top. Your lower goes on bottom. What you want goes in the middle. Remember, I subtract here. 70 minus 25 is 45. Okay, so remember, these are parts. I'm going to need 25 parts of 70%, 45 parts of the 0%, which is the sterile water. I'm going to get my total parts, which when I add those together, it gets me 70 total parts. And then remember here, I'm just going to kind of label these. 70%, so I'm going to take my quantity, which they told me was 1,000 mils. I'm going to divide that by my total parts, which is 70. Multiply times my 70% says I need 25 parts. That's going to tell me I need 357 milliliters of 70%. So that's part of my answer. And then I'm going to do the same thing for my water. And that's 45 parts here. And I get 643 milliliters of water. Of course, if you add these two together, you should get 1,000 mils. I'm going to stop there for ease of upload of the video.